Hello all, welcome back to this video on backtracking, a powerful problem solving technique used in many areas of computer science. Okay, so what is backtracking? Backtracking is nothing but a methodological way to explore all possible solutions to a problem by building candidates step by step. Okay, methodological way to explore all possible solutions to all possible solutions to a problem by building candidates step by step. Okay, whenever it becomes clear that a candidate cannot lead to a valid solution, we abandon it immediately. We abandon the solution immediately. Okay, and try different path. So whenever a candidate does not lead to a valid solution, we abandon the solution and try a different path. So now looking into a definition of what is backtracking. Backtracking is a systematic way to explore all the possible solutions to a problem by building candidates incrementally or step by step and abandoning a candidate, or also known as backtracking, abandoning or backtracking a candidate as soon as it is determined that this candidate cannot lead to a possibly valid solution. So as soon as we identify that the candidate does not lead to a possibly valid solution, we will backtrack it or abandon it. This is the concept of backtracking. So what is the goal? Think of it like you are exploring a maze. Okay, different steps in maze. Okay, think of you're like exploring a maze. You try different paths, and if you hit a dead end, you will back up and try another route. Okay, this is the best example for backtracking. This systematic trial and error helps avoiding wasting time on impossible solutions. So by following this systematical trial and error method, helps us avoid wasting time on impossible solutions or options. Okay, impossible solutions or options. So now diving deeper into the goal, to find all the solutions or one valid solution to a problem with the constraints by exploring the solution space depth first and pruning paths that violate constraints early. Okay, we can find all the solutions or one valid solution to a problem with constraints, sometimes constraints, by exploring the solution space depth first and pruning paths which are not leading to the optimal solution that violate the constraint at the early stage itself. Okay, how backtracking works. First, we'll choose the option which will explore for the problem. Okay, then we will check. First step is choosing and checking if the current partial solution is valid or not. If it's valid and complete, we'll record the solution. If it's invalid, we'll discard and backtrack the solution. Okay, and we'll repeat until all possibilities are explored or solution is found finally. We will repeat the process until solution is found finally. Okay, first we'll choose a candidate and we'll explore it and we'll check it if the current partial solution is valid or not. If it is valid and complete, we'll record the solution. If it's invalid, then we'll discard and backtrack and we will repeat the solution until the final solution is found or not. So what is the key idea? Backtracking is like a smart brute force. Instead of blindly exploring all possibilities, it prunes or cut off branches in the search tree that can lead to a solution, saving time and effort. Because we are not investing much time in solutions which will not lead to a proper option or the final possible solution, we are cutting down it or pruning or backtracking it, so it will save our time and effort. Save our time and effort. Okay, so as it is saving our time and effort, it is called as smart brute force. So what are the examples that are probably suited for backtracking? Backtracking shines in problems like n-queens puzzle, and Sudoku, graph coloring, subset sum, and finding all valid permutations and combinations. Okay. This is the general template for backtracking. If the current solution is valid and complete, we'll record the choice, and if it is not complete and which will not lead to final optimal solution, we'll backtrack it. This is the normal template followed, basic template followed for backtracking. So what are the advantages of backtracking? Simple to implement. It is very simple to implement. Can find all solutions or one solutions quickly if desired along with constraints. If the problem has constraints also, this can be implemented, backtracking can be implemented. Efficient pruning reduces unnecessary explorations. So not only pruning but efficient pruning is required to reduce unnecessary explorations. So what are the disadvantages of backtracking? Can still be slow for very large problems without good heuristics or pruning. So as we have already discussed, efficient pruning is important. Without good pruning, it can slow down the solutions for very large problems. Requires careful design of pruning conditions to be efficient. Okay, for the solutions to be efficient and to reduce the time complexity, pruning conditions play a vital role. Okay, so finally, backtracking helps us tackle complex problems. Backtracking helps us handle complex problem by exploring options carefully, stepping back when needed and moving forward when promising. Okay, we'll sometimes step back when the solution is not valid and we will move forward when promising. Okay. when promising. Thank you.